Hi, welcome to Simply Maker channel. Today I like to show you how to make this. The cordless T12 soldering station. The soldering station is powered by Makita 18V battery. I've made this for a couple of years. It's one of the earliest tools I made with the 3D printer. I use it regularly and it serves me very well without any problem. The performance is quite impressive. With a fully charged battery, it can heat up to 320 degrees within 30 seconds. The soldering iron handle is compatible with Hakko T12 tips, so it has an extensive collection of tips for you to choose from. Now, let's see how to make it. The soldering station consisted of two main parts: the battery mount and the enclosure. The enclosure is modified from a 14-volt system, designed by FASTENING on Thingiverse. It's included 3 print parts: the main box and 2 mounting plates. The top one is for the step-down power supply, and the other one is for the T12 control board. You can find the full list of electronic components needed for this project in the description below. We will start with battery mount. The battery mount is originally designed by Bits on Thingiverse. You can find the link in the description. I modified it to fit with Makita's terminal block that I currently have. The one I have has an extra small pin extended from the body, so it doesn't fit the original mount. The battery mount is split into 2 parts, with a terminal block sitting in between. We need to apply some glue to hold them together. Use acrylic glue or epoxy for strong bonding. Apply a thin layer of glue to the part's contact surface. Use a couple of clamps to hold it together, and let the glue dry. After it dry, the part is extremely strong. Let's continue with the enclosure. Start with the power supply. I use this 5 amp step-down module that included an LCD display. The display will show real-time voltage and current. The main role of the PSU is to control the output voltage to the banana connector when you use it as a mobile power supply. The T12 controller board itself requires input ranging from 12 to 24 volt. The PSU is a step-down module. This means the output will never exceed the voltage delivered by the battery. So it's perfectly safe to use with the T12 soldering kits. The maximum output from my fully charged battery is around 20 volt and gradually decreases while using. To attach the power supply to the plate, we need to remove these 2 blue connector terminals. Use the desoldering tool or desoldering wick to remove excessive solder. While applying some heat, use the punching tool or awl to push the connector out. Next, we need to solder the wires to the board. This is the diagram that summarizes all the wiring. Start with the board's input. For in+, I use red 18 AWG wire. Crimp one end with a female spade connector, which will connect to the first switch. Then solder the other end to the board in+. Do the same for the in-, but use a little longer black wire. Here are all the input wires connected to the board. For the output, we need to connect the output to the banana connectors, and also to the T12 controller board. On negative output, use 2 black wires and twist them together. Solder the twisted end to the banana pin. Use a heat shrink tube to cover the contact. Crimp one end with JST-XH connector. This one will go to the T12 controller board. Solder the other end to out minus. On positive output, also use 2 red wires twisted together. But use a regular spade connector, instead of the JST-XH. This one will go to the second switch. Attach the heatsink to the power supply board with the supplied double-sided tape. Stick it firmly on the area marked with a white silkscreen box. Insert the blue button cover caps into the provided holes on the top plate. The button caps are supplied with the power supply kit. Then attach the PSU to the top plate. Carefully align all 4 buttons head into the button cap hole. Make sure that all the buttons can press down and spring up freely. Use button head M3 screws to secure the power supply board to the plate. Insert the power supply into the enclosure case. Secure them with 4 M2 flathead screws. Insert both switches into the enclosure socket. The socket will be a tight fit. If it's too tight, you can file the socket out a little. But the switch should snap into place. Connect the red input wire to the first switch. Crimped additional red wire with the spade connector on both sides. Connected one end to the switch connector. The other end will go to the battery's plus pin. Connect the output wires to the banana connector. Connect the red output wire, with the spade connector, to the second switch. Attach the enclosure to the battery mount base. You can rotate the battery mount direction to set the direction for inserting the battery. It totally depended on your personal preference. Connect input wires to the battery terminal. Please make sure that the red wire, from the first switch, connects to the battery plus pin. And the black input wire connects to the battery's pin marked with a minus sign. Secure both parts with 4 10mm socket head M6 screws. For the soldering iron, I purchased a T12 soldering iron kit from AliExpress. The kit included all the parts you need for about $12. The kit includes a controller board, handle, 1 iron tip, aviator plug, all the wiring, and even some spare parts. To assemble the controller board, start with the LED. Insert the LED's pin into the PCB. Please make sure that the long pin goes to the pad mark with a plus sign. Use small soldering iron tips. And carefully weld the LED pins to the board. Make sure that the tip does not touch other electronic components around. Insert the female aviator plug into the front plate. The aviator plug has a mark for aligning the pins together while connecting. Make sure that the mark is aligned to the top side. Insert a washer and screw in the aviator plug's nut. Attach the controller to the front plate. The aviator plug's pins should be aligned with the PCB pads. Make sure that all pins are fitted perfectly with the PCB. Push the PCB to the plate until the rotator base touches the front plate. Insert a washer into the rotator and screw in the rotator's nut. Use a wrench to tighten both nuts. Make sure that the aviator plug's nut does not exceed the print part. Again, use a small soldering iron tip to weld all the aviator plug's pins to the controller board. Use another red wire. Crimp one end with a spade connector. And another end, crimp with JST-XH connector. Connect the spade connector to the second switch. Use a 3-pin JST-XH male connector to connect the input wire to the controller board. Insert both wires into the connector housing. Make sure that the red wire goes to the plus pin on the controller board. Please recheck the marking on your board for the wire orientation. The pin orientation may vary depending on the controller board version. Use a cable tie to hold both wires together. Connect the JST connector to the controller board. Attach the front plate to the enclosure and fasten them with M2.5 flathead screws. So, we finished with the enclosure. Now, it's time to insert the battery to test. The screen will show 500 because the soldering iron cable is not connected. Now, we will go to working with the soldering iron handle. Start with connecting the cable to the handle. First, welding the vibration switch to the PCB. Make sure that the switch's pins go to the correct pad hole. The vibration switch pins are marked with gold and silver. Next, connect all the wires according to the diagram. Here is what the PCB looks like after wiring. Insert the PCB into the handle. Rotate the PCB until it aligns with the groove inside the handle. Slide the PCB into the handle until it sits in place. Screw in and tighten the handle cap. Then insert the iron tip into the handle. Next, we need to connect the end of the cable to the aviator connector. Remove the shell from the connector. Loosen the wire clamp screw and insert the shell into the cable. Measure the appropriate length of wire required for proper connection. Make sure that the cable clamp will be clamping on the outer wire sheath. Trim out the excess wires if needed. Strip out each wire sheathing for about 2 mm. Prepare the wire surfaces by applying a thin layer of solder to each wire. Solder the wires to the aviator connector. Each pin will have a small number embossed on the front of the connector. This indicates the pin's number. Follow the diagram and carefully solder each wire to the pin. Take your time, and double-check the pin number before connecting. Assemble the connector and the shell. Tighten the clamp screw. Now, the handle is already finished. Let's plug it in and test. Turn on the first switch. This is the main switch to control the power from the battery to the power supply unit. The second switch is for the soldering iron. If the default boot of the power supply is set to off, you have to press the lower left button to turn on the board output. Now, the red LED light is turned on. This means the soldering iron is heating up, and the screen will show the current temperature in Celsius. To adjust the temperature, just rotate the rotator knob. To set the default boot of the power supply, long press the lower left button and release. The screen will show the new default boot setting. If set to on, the output will turn on automatically when the PSU gets the power. If set to off, the output will turn off when the PSU gets the power. You have to press the power button to turn the output on. This T12 handle has a vibration switch to wake the controller from sleep or shutdown state, and heat up to set temperature when you pick up the handle. There are some settings needed for this function to work properly. Long press and release the rotator knob to enter the setting. Short press to select the menu. Go to menu P05. This is sleep time in minutes. Rotate the knob to change the value. When in sleep state, the soldering iron will decrease its temperature to 200 degrees. To save battery, I set it to 1. Short press to save and switch to the next menu. Go to menu P06. This is shutdown time. I set it to 4. Go to menu P08. This is wake mode. Set it to 0, to enable the vibration switch. You can also rotate the rotator knob to wake up the controller. Go to menu P11 to save and return to heating mode. All other menus are mostly for calibrating and fine-tuning the controller. It's a good idea to leave it to factory default. I also included the link to the controller setup document in the description. That's it. I hope you enjoy your new soldering station as I do. If you have any questions, please feel free to add them in the comment. And if you found this video helpful, please consider giving me a like and subscribe. Thank you for watching.